Buenas tardes, ¿me escuchan? I'm right here. I'm right here. Okay, I'm going to give it a few minutes for the class to log in. I am going to use YouTube mainly for two reasons. Well, there's many reasons, but one is so I can put timestamps into the video. So when you review it, you can go right to the timestamp of the section you want to review. And I need to bring my microphone closer. And I'm going to use it so that you can translate into the language of your choice. All right, so this should work to caption everything I'm saying. Once the video ends, you can use the tool key, otherwise known as settings, to set up the translation. And if you don't know how to do that, you can find a YouTube video or you can ask me. All right, so let's see who comes in. I'll just give it a couple of minutes because I know I sent the invitation rather late. I've worked on my sound, so this should be good and you shouldn't hear any loud noises. Like I say, I really like streaming on YouTube for many reasons, but I've named a couple. So I'm going to pick up where we left off, and again, encourage you to work on reading through chapter 1. And I still have to post these notes for you, and I'm going to post the answers to the discussion topics. You can write in the chat. You can text me if you have comments or questions, or you want me to answer something and you can't make it to the meeting. The meeting or our lecture today and the other days is not required. You don't have to attend, but you should watch the video within 48 hours, I believe I mentioned, in a timely manner. All right. See how many people log on. I'm watching in another stream to see the product. There's a little bit of a delay, so just to warn you, I might be talking about things and then, I don't know, things might be out of order. I might talk about a chat that you don't, an old chat or something like that. Just that there's a delay, it's a slight few second delay between when I say things and when you hear them. All right. All right, so also I was able to connect my iPad directly to the computer, and this should help the flow of the keystrokes or anything that I'm gonna sneeze again. All right, so any comments or questions? Hello, Alejandro. Funny, I just started sneezing like crazy. Okay. Right, so let's continue where we left off. And I asked you, at least because I didn't share the slides with you, you didn't work ahead, so I can work through them steady. All right, so where we left off, we were talking about the time value money relationship. Oh dear, is that so funny? Okay, I think I can fix that, but I'll fix that later. Thanks, Ricardo. It's always something. All right, yeah, any other comments? Oh, what did I put in the mail I sent to you? Use the right day. It's because this video was set up for another course and it saves title sometimes. And anyway, I just ran with it. January in it. Okay, so it looks a little bit blurry. If your screen looks blurry, reload, okay? If the screen looks blurry, reload the page. I don't know why that happens. That's a good explanation. So if the screen appears to be blurry, reload the page. All right, so let's see. Okay, so we left off here. So we were talking about the time value of money relationship, which is this one. Formula, or this relationship between four variables. And what we did was solve, given three variables, solve the fourth. So that's mathematically what's going on. Theoretically, what's going on, this is the basis of finance, right? This relationship between the periods of time. And what about the last variable? So we solved for the present value. We solved for the future value. What about, and we solved for the interest rate. What about time? How do we solve this problem? How long does it take an investment of $1,000 to become $10,000 if the rate of return is 8% per year? So we have the same elements. So with the prevailing interest rate of 8%, we have this one. We have the principal amount invested, the present value of 1,000, and we have the future value, what it grows to 10,000. We want to know what is the rate of return. So remember I said to you that I would have different labels depending on the context or the problem. Well, in an investment scenario, we would refer to it as a rate of return. Okay, so already we have talked about rate of return. Oh, sometimes it loses connection. We talk about I as the interest rate or the intrinsic rate of return to an investment. All right, so you can solve this using your calculator just like we did before, but you should also know how to solve it mathematically. Right? You should also know how to solve it algebraically or analytically. So try that in your finance calculator using these steps, remember, and I'll do it too on mine. The trick, you're entering cash flows into your calculator, all right? Calculator needs to be able to convey whether you're spending the money or you're receiving the money. So this is a cash outflow as your investment of 1,000. There are no payments in this problem. And you'll receive 10,000, so that's a positive. And you get the result. Anybody not get the result? Good turnout. 19 students at least logged in. Well, it could be other people. And it's 10 at the moment. Great, Ricardo, thank you. Who else gets the number? The result, 29.92 years. So how you're going to use the textbook is as a reference, largely, as I'm going to proceed with applications of the things that I'm teaching you, and we're going to solve problems together. And if there's terms you don't understand, you can go right into the textbook. There was a word that many of you questioned, that word leverage that you heard in the documentary I asked you to watch. And I want to give you an example after we finish this of leverage. Anybody else get the answer without problem? If you neglected to use the negative here, you may have gotten an error. Off. No questions, no comments, text. All right. So how do we solve this analytically, algebraically? How do you do this by isolating t? Do you know? You take the expression 10,000 and we want to isolate t. So the first thing to do is cross multiply, and that reduces the left side to 10. And then what do I do? Okay, I'll go back. Alejandro, okay, I'll do it in the calculator myself first. Okay, go and do that, and we'll come back to this one. All right, remembering my TBM keys, I need to have them clear. So clear TBM, then I start with years I don't know. That's what I want to find. So I'm working from left to right. So on this row, working from left to right, and I don't know, but interest was percent. I have to go back. Sorry. 8%. Okay. It was 8%, and remember, you enter as a percentage, as a whole number. The present value is the amount that you invest. So we invested 1,000 with a negative in front using this toggle key, and that goes into PV. And there's no payments in this problem. You'll understand very clearly what payments are later. But there are no payments in this problem. It's a lump sum of 1,000, and that 1,000 becomes 10,000 positive that goes into there. And now I compute the years. Compute here. Can you guys see the screen? Oh yeah, I do. Okay. I'm watching a YouTube stream that's delayed. Okay, so that's it. And we interpret it as 29.92. If you want to round it, practically 30 years. All right, so that good, Alejandro? All right, now let's finish the analytical solution. So what is to isolate t, we have to perform the inverse function. So what's the inverse function for the power of t? So exponential functions and logarithmic functions are inverse, so we need to perform a logarithm, natural logarithm on both sides. And when you do that, the exponent and the logarithm cancel, and this gives you t log 1, 0. So you're going to be required to remember from your MECU classes or your math classes in high school how to do this. So this is practical for you here. To finish the question, you isolate t. I'm often cleaning. And then isolating t is equal to log 10 over log, or natural log, 1.08. Now I have to show you how to enter that as well, right? Enter that. We have to press the number first and then the log symbol, log key. So I will share these with you. You should take notes for practice. I'll do it right after class. Unfortunately, excuses aren't great, but I did have a lot of things to do after last class. Okay, didn't have a chance to post. So we're going to calculate 10 log, so 10 natural log, you see that here? So 10 log divided by 1.08 natural log equals, and you get the answer. So the calculator has these functions programmed into it. Whether it's, well, the time value of money function is programmed in, and possibly all the solution functions, I'm not exactly sure, but at least I know the time value of money function is programmed in. And whether it solves by iteratively putting suggested values in there to solve it, or it actually makes the same, it uses the same formula like we did here to solve for time. Not sure which one it does, but anyway, it works. This is the base of what it does, that relationship. All right, so we get the same answer. Got the same answer this way. So you should be able to do both. So let's take a moment to talk about what I expect to see on exams. I mentioned to you, for the exam, you need to begin to organize yourself, right? This exam will be open book because this is a completely online course, but it's really important to organize yourself so you can use your time wisely. And I will give you a formula sheet to start, and then you can print that and then add on to it formulas that you use. What I want to see in the exams is this formula with the, so I want you to, you write out the formula that you're using with the values included. You do not have to show these steps of the key functions. This is not going to get you any points. So what I'm going to do is exams will be mostly multiple choice, and then you submit your solutions for part marks. You have to show me your work to get the points. So what I want to see is this. You don't get any points for telling me what you put in the calculator, but you do get points for the answer. So I want you to use your financial calculator. Some students will do this the long way. I mean, I can't stop you from doing it. However, you will find at some point you will not be able to use algebra, that you're going to have to use the calculator. So I encourage you to use the finance keys. I'm going to say this is not required, but I'm not going to penalize you. But you're going to penalize yourself if you try and solve everything mathematically. My note is you must learn to use the financial calculator. Although I don't give you any points for telling me what keys you're punching, I want to see what is behind or what's in the black box of your computer or your calculator. Right? I need to see the formula. And this is not going to get you any points. If you just write out this formula here, no points. Okay, so I need to see the formula with the values entered. Got it? Okay. Let me step back a moment and let's go back to this exercise that we talked about earlier on, which was finding the present value of $1,000. So what is $1,000 in 2 years worth today? And remember, we had that discussion, and I introduced the idea of discounting. And I did say there's another way to think about this. The other way to think about this is, what can I do today? What action can I take today knowing that $1,000 will be received in 2 years? What action can I take? Knowing that $1,000 will be received in 2 years, regardless of how much money I have, this interest rate is prevail. This is accessible to me, 8%. So I have access to financial markets at an interest rate of 8%. It means that I can loan money and I could also borrow money. So because I know I'm getting $1,000 in 2 years, I can do something. I can say, I can use that as for leverage. That's where the word leverage comes in. I can use it and say, well, I'm getting $1,000 in 2 years, so I could actually borrow against the $1,000. And right now, today, I can do what? If I borrow against 1,000, what can I do? What am I saying I'm going to do? problematic because I have to wait till you see this comment. If I remove the delay, I can't use some of the devices. So I'm going to sit and wait. I need to resolve. Yeah, I don't know. The questions are going to be very useful here. I'm going to have to just speak. Okay, so I can borrow against, meaning I can borrow $857.34 now, and then when okay, so and when 2 years comes around, I receive the 1,000 and I go back and I pay back to financial markets, whomever I borrowed the money from, I pay back the loan. How much do I have to pay back? Well, I have to pay $857.34 with 8% interest. So that will be $1,000. All right. This is known as leverage. And because of leverage, thinking I'm going to, what am I going to do with the $857.34 now? I could spend it. Could spend it. I could also, if there's 8% available to me, I could also imagine other possibilities of what to do with it. Okay? But at this rate, if everything is for certain, I'm going to get the 1,000, 8% is available. I can borrow against it and have $857.34 in my pocket today. That's the real value of it. Right? So that's an example, a very simple example of leverage. Now, in the video you saw in the documentary, they were leveraging on top of leveraging on top of leveraging. They were imagining, you know, they were borrowing against what they expect to have returned to them, right? So they expected mortgages to be paid, and they expected to have so much in terms of revenue that they could also lend those amounts, or they could borrow against those amounts. So that's the kind of leverage that you saw in the documentary, in the case of mortgages. So I'm just showing you a basic example. Did it make sense? All right. So this is a summary of the formula And I've written it also this way because I want to emphasize accumulation and discounting. So I talked about accumulation and then discounting. So making a last effort to share this terminology with you. You have accumulate, discount. Remembering T is the duration of the investment. The interest rate is I. The PV is the present value or the principal amount invested. And the future value is FV, the accumulated amount. And note that when we use this formula, we're always operating from end to end or beginning to beginning. I did not make a big deal about this, but this can complicate things. So in your timeline, you have to be sure when I write this, I am implying or insinuating that the payment was made, the cash outflow, at the end of 0 or now. And then this inflow was received at the end of T. Okay, later. So just to be sure, that's how it works. Or you can refer to this as the beginning of year 1, and this last one, the inflow, at the beginning of T plus 1. Right? So both of those are correct. You just got to be sure that you're applying the formulas properly. From end to end or beginning to beginning. All right. Okay, so we're going to get into, now we're going to move, so I showed you the time value of money formula. We use the formula relationship to solve one variable, knowing the other 3. And I introduced the idea of the interest rate being called different things in different settings. All right, so here let's apply what we learned so far, or what you knew coming into this course about making an investment. You believe that if you buy a hotel for $3 million, today you can sell it in 5 years. Sorry, did that wrong. You believe that if you buy a hotel for $3 million today, you can sell it in 5 years for $4 million. The prevailing interest rate is 8%. Should you buy the hotel? How do you think about this problem? Just watch the chat. You guys watching? Any thoughts? How would you figure this out? How would you solve this? How would you think through this? No ideas? Come on. All right, you guys. Join me. A little chopped off. No thoughts. Absolutely none. Well, you might think what you're supposed to do here is compare buying it to not buying it. So buying it for 3 million, you'll have 4 million in 5 years. If you don't buy it, what do you have? So if you buy, this is what it looks like for you. $3 million cash outflow and then 4 million in year 5. If you don't buy, what will you have? What's the option? The option is to, well, the option is to do nothing, but that isn't so smart, right? You should think of your next best thing to do. And the best thing to do is do not buy. Instead, invest or lend in the financial markets at 8%. So the very existence of 8% forces you to do something. So in that case, 3 million will be a cash outflow. And how much would you have at the end of 5 years? You guys can hear me, right? How much would you have at the end of 5 years? It would be future value 5. You can use your finance calculator to do that. Anyone get a number? That's what you. $4,407,984.23. Oh, good, Ricardo. Thank you. Right. So that's how much you would get. So how do you conclude? What is the conclusion? The conclusion is that this is a better option, right? What's the best option? Do not buy. but it doesn't mean don't do anything. Instead, invest in financial markets. So, in fact, this is the right answer. Let me step back a bit and say, okay, so I narrowed it to two things. I didn't give you the option of doing nothing with the money. Okay? A rational person, that's what we say in economics, a rational person would not forego this opportunity. If they had the 3 million and they were considering investing, they would not purchase the hotel if these were your two options, and this is all that was to be considered. You would invest in financial markets. The very existence of financial markets makes you do something else. So, in fact, although we've got the right answer, the convention or the way we do things in finance is different. The way we do things in finance is we convert monetary values to present value terms. The reason we do that is because we know the purchasing power of $1 today. We know the purchasing power of $3 million today. In fact, $3 million can buy you a hotel today. We know what it's worth to have 3 million today. We have a sense of what it's worth in 5 years, and we have, we figured out with financial markets with an 8% rate, and assuming that it's going to be 8% in all those years, we come up with this figure, but in fact, we don't really know what's going to happen in the future. Nobody does. So the convention is to convert values to, if you can guarantee, the 8% return here, that's over the 5 years, then you can also just as well calculate the present value of each alternative. You've got to put together the cash outflow and the cash inflow and come up with called the net present value. So that's what we're going to do. The net present value is equal to the investment cash flow. Notice it's CF0. CF0 is the initial cash flow, and it's going to be a negative because it's an investment, right? So this is going to be a negative value. Even though I didn't put a negative here, it's going to be a negative value. I can just make a note on the side. Note. Negative. Now, every time I use symbols in this class, and I'm going to use a lot, they should not intimidate you. They're meant to simplify things. If they intimidate you or confuse you, please ask me what's going on, okay? They're meant to help and simplify things and simplify communication. But understandably, they're not simple, right? They can mean a lot. So this one is going to be a negative value. So that's the initial cash flow. And then we're going to offset by the present value of future cash flows. And we know how to calculate that because we learned how, with the basic time value of money, we're going to extend it to more than 2 years. So this is 5 years discounting on the 4 million. So we discount this for 5 periods all the way back. That's 5 periods, 5 discount factors, and then offset with the negative. So if you were to calculate that, what do you get? Get me a number. All right, I can't give you too much time to respond because we're never going to finish. But please do try. Otherwise, it's just going to be lulls for nothing. So you should be trying to put this in your calculator. What you can do is use the financial keys to discount this for 5 years and then take off the 3 million. So let's do that. And then I'll show you an easier way. So I'm going to go into my TVM keys and I'm going to clear the third row. And for 5 years at 8%, I'm going to enter not the present value and payments are 0. I'm going to put 4 million. 4 million. And then I'm going to compute the present value. So that is the present value of $4 million. Very good, Ricardo. Yes, so then you take this and then okay, so the confusing part is I should have put, all right, so it comes out as a negative in my calculator. I have to make it a positive because that's what I get, right? So I got to change the sign. You got to keep track of the sign, so you're really going to have trouble. So I put a positive 4 million, so my calculator will give me back a negative, but for this problem, this is supposed to be a positive amount because it's what I'm getting. This is the present value of the 4 million for the hotel if I sell it in 5 years. So then I'm going to subtract off the 3 million for the initial purchase, and I get this amount that Ricardo got too. Great. So that is what's called the net present value, but I'm going to show you how to use this key here instead to calculate that, all right? Let's go back and put that number in. Thank you for writing it in the chat because I can just copy it. So the value was 277,67721 if you just use that formula. And now I'm going to show you how to use your finance calculator to get it using the NPV keys. We're going to treat this, each of these are cash flows, right? So we have the initial cash flow, initial investment, and then we have cash flow, the end of period 5. Oh, I have to put the negative on here before I forget. So the result is a negative, and the rule for NPV, so the net present value rule, is invest if the NPV is greater than 0. If it's not, don't invest, right? So it has to be a net positive. Otherwise, do nothing. At least don't invest. So in our case, the answer is do not invest. Negative. Okay, let's look at how we enter this into our calculator. So what you're going to do is go to the calculator and you press CF for cash flows. We're going to use the cash flow worksheet now to enter these values. And we have to make sure it's clear. He's scrolling through, I have numbers in here, right? So I need to clear this before I begin. So we use second and now clear work. Clear work is clear worksheet. So we clear the worksheet and we're ready to go. In the initial cash flow key, we enter $3 million invested and it's a negative, right? We enter and scroll down. So that is the initial cash flow. And this is a worksheet and it doesn't know exactly what you want to do. You have to give it a little help. You have to, because the values are, so this is going to be the amount, cash flow, or C1, C01, and then F is the frequency of those. So we're going to take advantage of this and enter, well, we're going to put a 0 because nothing happens for 4 years. So it's going to be 4 years of 0. So we have to put a place mark. You have to tell the calculator that nothing happens for 4 years. Otherwise, it doesn't know the way that it's set up. So we have to fill in those with 0. So I say 0 for C1, enter, and I scroll down, and I have to tell it how many zeros are there. There's going to be 4 zeros. So I enter and down. And then I go to C2. Now, this is not the second cash flow. This is the second amount. I have 4 zeros and then 4 million. I'm going to put that in as my second amount. And that's all I'm going to put in the calculator. So it's going to be 3 million initial cash flow, nothing for 4 years. That's what the F014 means. And then $4 million. That will be on the 5th year. The calculator will keep score, keep track. And when we're done, we're sure we've entered everything correctly, you compute NPV. Those are part of the same row. It's part of the same worksheet. It needs to know the interest rate. So the prevailing interest rate we're going to use is 8%. We enter it and we scroll down, and it asks us, or tells us NPV is 0. Well, just because we have to ask the calculator to compute NPV. So now hit compute, and that is the same number Ricardo got. Want to see it again? Now, as I'm speaking, I can see that the captions are appearing. I don't know if it's going to translate automatically, but anyone who wants to check that, let me know if it's translating automatically too. It would be interesting. Yeah. Novelty for me, but I assumed eventually it was going to be able to work. Okay, one more time. So let's clear. So I'm going to clear the second clear the worksheet. And oh, I have to see the CF, I guess, is different from the NPV calculation, so you have to do it again. So I cleared the CF keys, clearing the CF keys. Now we're going to enter the 3 million investment. So 3 million with a negative. So you say 3 and then 0, 0, 0, 0, 0, 0, 6 times per million. So that is entered, and scroll down, and you only want one of those. That's all there is. Only one initial investment. So now the cash flows, we're going to put a 0 into C1, and we're going to tell the calculator that we want to repeat that for 4 years in a row. So 4, enter, and scroll down. And the last amount is the 4 million, 0, 0, 0, 0, 0, 0. And that's a positive, right? Keep it as a positive. Enter and scroll down. We're done. We only want one of those. So just review the numbers. 3 million as the initial cash flow negative. 4 zeros and 4 million at the end. All right. So after I do this, I'm going to show you on the slides all the steps. Okay. It's a lot more involved. It looks more menacing than what I just did, I think. If you got it now, that's great. So now we hit NPV, and the calculator wants the interest rate, or the rate of return. So it's going to be 8. Enter. And scroll down, and now you ask the calculator to compute NPV. You mean when you're looking, Coral? So what I'm going to do, Coral, is I'm going to show you the slides. So let's show you the slides and it'll be easier for you. Okay, so those are the steps. So try that. Okay, Coral. So review the steps here. All I did was I changed from here. I made it a little easier by converting that to CO1. I said 0, enter, on 1, and then what happens is it says FO1, and then we put 4, enter. That's what we did. Again, don't forget, if it gets blurry, refresh the screen. I'm going to check if anybody contacted me about that. I don't really check my WhatsApp. If you want to text me, I have an iPhone, so just iMessage me. If you have to use WhatsApp, use it, but there might be a delay because I don't always check it. Okay, I'm just letting you try that. Please try it in the comfort of your space, wherever you are. Hope you're comfortable. Change the name. Kind of scared. Wait till it's over. We have 20 more minutes of class. Do you have any comments or questions for me? Let me know if you're able to get the calculation. There's 8 students watching. Students are in and out. Can't see who's watching. I can just see the number. Unless you text me or chat. I don't know. Private that. No comments, no questions. Everybody's good? We're going to move to the next problem. Oh, let me just say for the exam, what I want to see, great. What I want to see for the exam is that you write this whole thing out. Don't want to see for full marks. You have to write this whole thing out, okay? You have to show me, you have to demonstrate that you see that this is an application of the basic time value of money again and again and again. Time. So you've used the basic time value of money formula 4 times. Discount each amount. Ricardo, don't worry. Just watch me and replicate. I mean, once you have the first exam, you have a better idea, I guess. So I will post some sample exams for you to get an idea of what I expect to, okay? So it's problems like this. And I want to see all of this, and I do not want to see this one will not get you any points. Don't write this down on the exam. There's no points. Okay. Coral, I'm going to most likely give you an exam in Moodle. I don't think I'm going to use Connect. Connect will be more for like review, and probably the final exam will be in Connect. But you will use the Moodle platform. I haven't decided completely, but what I did last year was I made my exams and students answered multiple choice questions in Moodle, and then they sent me their written work so I could give part marks. So that makes sense. So if you made a calculation error and it was a modest error, I wouldn't penalize you 2 points. Got the wrong answer, just 1. That's the best way, I think. I put it in Connect. I think I put the final exam in Connect. But not all the tests, because I think my tests are better. Okay. You'll see. Once we get through the first test, you'll get the hang of it. All right. Okay, so this was not a profitable investment because just sitting around for 5 years doing nothing with the hotel didn't generate any revenues. What if we try and generate revenue by renting the hotel in year 4 and 5? Or sorry, 3rd and 4th, because it ends in 5 years. So in 5 years, we're going to get 4 million, but in the 3rd and 4th year, we're also going to make 200,000. Now, note, I'm going to assume that that's the end of the period amount, okay? Even though rental income could be earned at the beginning of the month, I'm going to treat it as end of month earnings, okay? So I don't have to, anyway, so that's going to be like here. You can think of it as it's going to happen here. So that's the end of the 3rd, but the beginning of the 4th, and the end of the 4th and the beginning of the 5th. So you can think of it like that. So what happens now? Tell me, should those $200,000 in those 2 final years offset the loss of 277,000? Have a look. Let me know. Try it yourself, and then I'll show you. Remember to refresh the screen if either the screen is blurry or it looks like I'm talking about things that are a long time ago. There might be a delay. I'm not an expert in YouTube, but I do use it. There's just a lot of things. I have to enunciate and speak clearly. This is a really good test for me. So what do you get? Anybody? So in this case, you could go back to the values that you already entered, and all you need to do, you have to change the zeros that you put in C01, make it 2 instead of 4, and then I guess you have to change the whole thing. So then you're going to have 200,000 for 2 years and then the 4 million. So you can do it all the way through, or you can Or you can use the method I mentioned where you're doing frequency. Face camera. Okay, so what's the conclusion here? That's right, Coral. So yeah, so now the 28,000. So basically, the rental income offset our loss. Our net present value was negative. Now it's positive. It's 28,000. So you invest. If you use the rule that NPV must be greater than 0, that's enough to justify investing. So NPV is an extension. We're applying the time value of money. We're putting together the decisions, the two choices. I'll do alternatives, right? Financial investing in the financial markets versus this alternative. And in this case, we should invest. Okay, let's see if we can do, yeah, we have time to do one more thing. So as an extension, anybody who feels I'm going too fast, let me know. Make sure you can get the number. If you want more time, let me know. All right, so here is a similar problem. This is a problem of mixed cash flows. So imagine that there's an investment opportunity that promises to pay you these amounts over the coming years. So they're different amounts. That's why we call this mixed cash flows. And this is possible if you invest, let's say, in a mutual fund. And looking at the projections, you've been told that you can expect low returns in the first 2 years and a little bit more in the third and fourth. So you come up with these numbers, or someone suggests these are the returns you can expect in each year. So a mutual fund is a fund that many people together, individual investors, invest in it. And by drawing a pool of people's money together, the portfolio manager has access to invest in a particular way that they might not otherwise have access. So they can invest in private equity, maybe, that they couldn't have otherwise, right? So they have, by pooling money, you can make more money because there's more opportunities, more risky opportunities. So that's better than investing as an individual investor. So people are attracted to mutual fund investing, and this is just an example. Let's see what the required rate of return. So here's another word for interest rate. So we're just going to use our same approach as before. The required rate of return, that's going to be like our interest rate. So investors in this fund or this opportunity will use 8% as their opportunity cost, right? This is another way to say it. It's the opportunity cost. They're going to put their money and lock it in for 5 years to get these returns, but they require 8% because if they were not investing here, they would be investing in financial markets at 8%. That's how it's a long-winded explanation of what that all means. And essentially, in mathematics, it's just the interest rate. So what do we do here? The difference between this and NPV is I don't know In fact, I want to find out what I should invest to get these amounts. However, these amounts will help me calculate the NPV. So what should I do? This is what we're going to do. We're going to determine the fair price as the initial cash flow, right? So that should be the initial cash flow. The initial cash flow offset by the returns as the fair price. This is going to be a negative. These are all positive. To be fair, the most that somebody should be willing to pay would make this become zero. I have to write a little neater. You agree? So the most an investor is willing to pay will make this equation zero. If they pay less, the equation will be greater than zero, and you should invest in it, right? Because you paid less to get more money than you paid for. So this is the equation we're going to work with to put this into our formula, or to put this into the NPV formula that's programmed into our calculator. We are going to flip these two terms. We're going to use zero as the initial investment, these as our cash flows, and then the result will be the NPV, which is in fact how much we should invest. In other words, this is what it's worth. Okay, so we're finding the value of mixed cash flows with our calculator, just like we did before, but the interpretation is that this is our initial investment. This is the fair price. So have some time, try that and see what you get. Remembering that CFO is a negative value with a negative in front, that makes NPV a positive. Are you trying it? How's the sound? I worked really hard to get the sound clear. And I'm blocking out a lot of exterior sound. Great. Great. What did you do wrong, Carl? Okay, so what you should find doing these steps is the number that Ricardo got. Don't let Ricardo get all the answers, guys. Ladies and gentlemen. Okay, right. So where is the negative? Well, you don't have to put a negative. Basically, the NPV will come out positive, and then you interpret it as, anyway, don't worry about it too much. But basically, this is what it's going to cost, or this is the fair price. Sorry, that's what it's worth to pay up to this much. Okay, so this is the most you'd be willing to pay. Okay, so I let you work with that. I'm going to put some exercises up, and I'll put up the notes, and anybody who wants to work ahead, you can work. Encourage you to work ahead. I should put a connect assignment up as well. But I'll see about that. See if we made enough progress to go there yet. Well, I'm very grateful for you writing the responses in the chat. That way I can go to the next page. Okay, so here are the 2 questions to think about and where we'll start next week. What we've talked about in mixed cash flows is very general for anticipated cash flows. Where can I find the command? Why did you need that? The absolute values? You want the absolute values? Tatiana? On the calculator, if you want to change the sign, not sure. So here is the plus or minus key, changes the sign. I don't know if that's the question you were asking. Ask me again. All right, so oh, the I. Sorry, yeah, the I. That's right. Thank you. Thank you, Carola. Or Coral. Thank you, Coral. Right, that is the I. That's right. So the I comes up if you hit NPV. You got the answer now? All right, so for this problem, we have 2 general questions. What if the cash flows are infinite? What will we do there? Now, we'll talk about scenarios where that is even possible. In terms of entering values into the calculator, it has to be finite. We can only enter a set number of values, a fixed number of values, right? We can't go on forever. In fact, mathematical equations of summations or infinite summations give us simplification formulas. This is in general the NPV formula, okay? But if these go forever, we need a better rule than this one because we can't sit entering values into our calculator forever. There's got to be some sort of pattern we can exploit, and the formula will help us with that. In particular, if cash flows are the same amount, that's going to make it particularly easy, right? So that brings us to this example. And this is where we'll start next class. Okay, so I will post these notes up, and I can post the markup notes too. That helps some students. And then this video automatically will display on YouTube. I'll put the link in the Moodle page as well, right, for people who haven't seen it. So about a third of you guys have shown up, which is fine. And I really appreciate it because you make it much more interesting when we have some exchange. We discuss the material, and I see where you're having problems, or if I'm making any anyway, if I'm making any mistakes. I don't want to say I do that too often, but you can help me if the sound is off or if I'm going too fast. You can keep me informed. So I really appreciate you guys joining today, and I'll see you again on Monday. If you need to communicate with me, you can email me, you can text me, and we'll see you on Monday, otherwise at 4 o'clock. For now.